do is to start filling your burette, because we will need to fill this up with sodium hydroxide next lesson. Today we're just using water. Now, for some of you, pouring is going to be harder. So, you are allowed to do this. You take it down, there. Then you can pour. If you still can't reach, you can take it down a tiny bit, so you can reach and pour nicely. Yeah? Okay, so what you're going to do is, when you are pouring your liquid in, this has got to be closed. Open, closed. Open, closed. I've seen students, they start pouring, and as they are pouring, it's going out. Right?
Welcome to Chem Plus. Welcome to Chem Plus. Today we've decided to look at titration calculations. Students do struggle with some of these calculations. Let's go. We're given a question there. The student found that 15 cubic centimeters of 0.5 mole decimeter. You've got to be very clear at the beginning. This is your concentration and this is the volume for the hydrochloric acid. Is needed to neutralize 10 cubic centimeters, the volume of sodium hydroxide there. Right. What you got to demonstrate on this kind of question is, do you know how to write a balanced equation? Yes, you do. Do you know how to write a balanced equation? There you go. Right. So just to be clear on what's happening in this experiment, your HCl is in the conical flask and your sodium hydroxide is in the burette. Let's go. What I normally do with my students is I ask them to use the table method. Let's go. I ask them to use the table method. We are given 15 cubic centimeters of hydrochloric acid and the concentration is 0.5. If you want, you can pause the video and then you can check your results later. What else are we given? We are given the volume of sodium hydroxide. From the equation, we can see that one of the sodium requires one of, so therefore our ratio is 1:1. Now, we got to use this formula below me here. Moles is equal to concentration times volume over 1,000. If we use that formula, we are going to get moles of hydrochloric acid. I can work them out for you. Moles is equal to concentration, which is 0.5 times 15 divided by 1,000. Using that formula there, we get 0.0075. If you are using a scientific calculator and you get 7.5 times 10 to the power minus 3, that's still okay. Now, what you got to do as a chemist, as a grounded chemist, is ratio is 1:1. So if we've got 0.0075 there, moles there, we are going to have 0.0075 moles here. Now the question is asking you to find the concentration of sodium hydroxide. That's the question. What is the concentration of sodium hydroxide? So you got to rearrange this formula here. You got to rearrange that formula. You got to rearrange it. Concentration is equal to moles divided by volume over 1,000. Right? So your moles is 0.0075, your volume is 10, and your answer, if you punch that in, your answer should be 0.75. Let's just check. Yes, 0.75.